Everyone, you may be surprised to see this diagram before I start a maths class. This is not a physics class where I am going to discuss a retractable telescope. What is a retractable telescope? This telescope, you can see that it has three parts. Part 1, Part 2 and Part 3. When this telescope unfolded, it has three parts. But once it is folded, you will see that there is only one part. Today's class, I will be discussing one of the most unique and interesting series, which is known as telescoping series. This series exhibits unique behavior that will test your knowledge of algebraic manipulation. Okay? These telescopic series are unique class of infinite series, maybe finite also, that allow for simplification due to cancellation of many terms. It will leave only a finite number of terms to complete the sum. It's very interesting. It may have finite or infinite number of terms. These three unique series you observe once. But when we find the sum of this series, the series will collapse into one or two terms. These are named because of this reason. These series are known as telescopic series because they have a unique property where most of the terms in the series will cancel out when you find the sum. As you add or subtract terms in the series, consecutive terms often have opposite signs and equal magnitude, making them collapse or cancel out when summed together. The term telescopic is used because of this concept. When you extend or open a telescope, you see a longer view, like in the previous diagram. When you open, you can see the longer view. And when you retract or close it, sections slide into each other, becoming compact, just one here. Similarly, in telescopic series, as you expand or open it by writing out more terms, you write more and more terms here, you'll notice that many terms cancel out, leaving only a few terms to determine the sum, making this series a concise and elegant way to express a series. So without wasting our time, let me start with this first one here. That 1 by 2, 1 by 6, 1 by 12. How to find the sum of this telescoping series? I'll explain first. This series, whenever you are going to solve, you need to find the nth term and then go by method of difference. Today's class, I'll be showing you only simplest examples to understand the telescoping series, and next session I'll be bringing very interesting problems on telescoping series, and we'll do all those step by step, one by one, with detailed explanation. Let us start with this, where it is half plus 1 by 6 plus 1 by 12. In this series, initially you will assume that there is no way to simplify it, just how to find the sum. But by using little bit sense of finding nth term, the series can converge to one or two terms only. Let us write the nth term of this series first. So let me write the nth term here. We'll write it is 1 by 1 into 2, 1 by 2 into 3, plus 1 by 3 into 4. This way, if you write the whole series, the nth term going to be 1 by, see, it will be nth term of 1, 2, 3. This is arithmetic progression. It is n, this multiplied by 2, 3, 4, like this, it is n plus 1. Okay. This is a finite telescopic series. In this session, I will be discussing finite telescopic series only. So for this series, what we are going to do there, we are going by method of difference. We observe that every term is actually difference of two terms like this. It is 1 by 2 minus 1 by 3. We need not learn method of partial fraction today. Just we use our common sense to find the sum here. 1 by 3 into 4, how do you write? It is simply difference between these two terms. How to write the last one? It is 1 by n minus 1 by n plus 1. Okay? Now, if you start finding the sum of this series, it is better in the first sum I write in details. T1 is what? 1 minus 1 by 2. T2, 1 by 2 minus 1 by 3. T3 is 1 by 3 minus 1 by 4. It continues this manner, and so long we don't write the nth term here, that is 1 by n minus 1 by n plus 1. So you can see that these terms are getting cancelled. Which one? This one. Telescoping series unfolded here. We have expressed the whole series as difference of two terms for each term. Now it is being unfolded by cancelling the terms. I told you, no, that's why it is called telescoping series. All these diagonal terms get cancelled. So Sn going to be equal to T1 plus T2 up to Tn. This is 1 minus 1 by n plus 1. The sum of the series is n by n plus 1 only. Okay. So many terms are there. It is reduced to this simplest one, n by n plus 1. Today's class, I have promised that we will be discussing only simple problems on it. So let me take the next example for you. For this second example of telescoping series, you will say that it's a common GP series. Of course, but today we will be solving this series by using that method of difference only. This time with different manner. And this is not infinite series, we will be discussing finite series only today. So for this one also, you write Sn in this form, that is half plus 1 by 8 plus 1 by 32 plus 1 by, this is what, 2 to the power 1, 2 to the power 3, 2 to the power 5. It will be 1, 3, 5, its nth term. This is another arithmetic progression. Its Tn is 1 plus n minus 1 into d. This is nothing but 2n minus 1. So this last term going to be 2 to the power 2n minus 1. Okay. We have to find this sum by using the method of difference. This time what I am doing there, the common ratio of this geometric progression is 1 by 4. So multiply both sides by 1 by 4. So to understand it in better manner, what I am going to do, I will be writing the previous term also. Let me rewrite this series again here, that Sn equal to half plus 1 by 8, 1 by 32 plus, what will be the term before it? If you write this is 2 cube, 2 to the power 5, it is 1 by 2 to the power 2n minus 3 plus 1 by 2 to the power 2n minus 1. This is telescoping series, and we will collapse its sum by applying this technique. We are multiplying both sides by 1 by 4. 1 by 4 Sn, you multiply this by 1 by 4 and start writing from here. 1 by 8, 1 by 32, 1 by, previous term was 2 to the power 2n minus 5, it is reduced to 2n minus 3, and when you multiply this by 1 by 2 square, it will be 1 by 2 to the power 2n minus 1, and next one if you multiply by 1 by 4, it will be 2 to the power 2n plus 1. Now if you are subtracting like this, then 3 by 4 Sn going to be equal to 1 by 2 that is 1 by 2 plus 0, 0, 0, all these are equal to 0 and they get cancelled actually. They get cancelled this manner. What is left over there? 1 by 2 to the power 2n plus 1. Okay? You can take their LCM, you add or you don't add, it doesn't matter. But Sn is found here. It is 4 by 3 half minus 1 by 2 to the power 2n plus 1. It's over. Sum can be determined by this method. This is very interesting. We went for that method of difference only, but this time with different method. So let us do this one also when it is 1 by 3, 1 by 15, 1 by 35. This telescoping series, we will find its sum just by writing the nth term. If you are able to write the nth term, then it is not a problem at all. So here Sn will be, let us write the Tn term first, that nth term first. What is the nth term here? You see the behavior of these terms. It is 1 into 3, the first term. The second term is 1 by 3 into 5 and it is 1 by 5 into 7. So if you want to write the nth term here, Tn will be 1 by nth term of 1, 3, 5. Nth term of 1, 3, 5. This multiplied by nth term of 3, 5, 7 like this. So this will be 1 by nth term of this is what? 1 plus n minus 1 into 2. This multiplied by 3 plus n minus 1 into 2 because common difference is 2 only. So it is 1 by 2n minus 1 multiplied by 2n plus 1. Some of you will be able to determine just by observing the terms. Their difference is 2, we will be writing 2n minus 1, 2n plus 1 only. Okay. Now let us write the nth term here. Nth term for this is, then we got Tn equal to this. Now Sn will be what? It is 1 by 1 into 3, 1 by 3 into 5, 1 by 5 into 7. This way 1 by 2n minus 1, 2n plus 1. Okay. Nth term we just found. We have written this manner. Now common sense, little bit common sense will help you to get this one. This one to express as difference of two terms. It is, we are writing 1 minus 1/3. We are writing 1/3 minus 1 by 5. But take care of the numerator. Numerator going to be changed. It is coming 2 over there if you subtract. So won't you divide by 2 first and then proceed? Yes. It is half into 1 minus 1/3. Half into 1/3 minus 1/5. 1/5 minus 1 by 7. Telescoping series is being unfolded, that we are writing as difference of two terms. 1 by 2n minus 1 minus 1 by 2n plus 1. Okay. Done. Now what do you observe there? That when you are going to find the sum here, just let me put a bracket here. We observe that this second term get cancelled with first term of the second bracket. This way, till what it get cancelled. So to understand this, it is better you write this method. T1 you write half 1 minus 1/3. T2 you write half into 1/3 minus 1/5. T3 is half into 1/5, 1/7, and then you write Tn. Tn will be half 1/2n minus 1, 2n plus 1. Okay. Now summation of this telescoping series is very easy to find. Decide these two get cancelled, these corners getting cancelled. Nothing is there to cancel with 1 and 1/2n plus 1. So Sn will be what? Half into 1 minus 1/2n plus 1. So on adding, 2n will go up, 2 into 2n plus 1. Okay, 2n plus 1 minus 1 in the numerator. So all get cancelled, and finally you get, when folded, it is becoming 2n by this or n by 2n plus 1. Okay. Today till this, I am coming with many problems, many different types of telescoping series. We will be discussing one by one. But this introductory class, I don't want to discuss the method of partial fraction to get the summation of telescoping series, and you have to wait for the next session. Thank you.